Welcome all. In this video, we are going to study about problems related to welded connections. So going for the first problem, a 200 mm wide, 16 mm thick plate is to be connected to a gusset plate of 16 mm thick using 8 mm sharp weld. Determine the lap length required to develop strength equal to full strength of the plate. The weld is provided on three sides. Okay, the problem is as explained, but the thing is you need to design the weld. So you need to design the weld for a load that is equivalent to the full strength of the plate. So first thing you have to do is you need to calculate what is the full strength of the plate. You can see the gusset plate and the flat plate what you are going to connect both has a thickness of 16 mm. Okay, so next we will go and calculate what is the full strength of the plate. Coming to the given data, the thickness of the flat is 200 mm, thickness of the flat is 16 mm, width of the flat is 200 mm. Assume grade of steel, it is not given, we will assume it as Fe410, and size of the weld is given, it is 8 mm, that means the throat thickness is 0.7 into 8, it is 5.6 mm. So from IS code book IS 800 2007, okay, from clause 6.2 and page number 32, you can calculate what is the full strength of a plate using this particular formula. So now here in this formula, that TDG is nothing but full strength of the plate, that is gross area you need to calculate. The formula is AG into Fy divided by gamma m naught. Here AG is nothing but gross area of the plate and Fy is nothing but yield strength of the plate, and gamma m naught is you have 1.10, it is from table 5 as I explained earlier. So here you can see the gross area of the plate is 200 mm is the width and the thickness is 16 mm, hence gross area of the plate is 200 into 16. Yield strength of the plate is 250 mm, and it is, see, you can see here the grade of steel is given as Fe410, that means ultimate strength is 410, whereas the yield strength is always 250 mm. So we have substituted this and we got the answer as 727.27 kilonewton is the full strength of the plate. And next we have calculated full strength of the plate. Now we need to design the weld for that particular load. So area, the load what you have to consider here is the full strength of the plate. Now in order to design the weld, size of the weld is already given. You need to find only the length of the weld. For that we have the formula full strength of the plate, that is P, should be equal to area of the weld into stress of the weld. Area of the weld is nothing but length into throat thickness into stress. Stress is nothing but FWD, and it can be calculated using this particular formula. This we already discussed in the previous video. So just substituted all the values and we can find what is the value of L, and we got the answer as 685.79 mm. Okay, we will round it off to 690 mm. Hence provide on three sides of the weld, that is you can provide it on the three sides of the weld, three sides of the plate, that is you can weld. One side is this one, this is our one side, second side is here, third side is this one, this is our third side. So three sides will weld, and total length of the weld is what we got in the next, that is 690 mm. So if you weld it on the one side, that is, you can see here the question is you need to calculate the lap length. Lap length is nothing but the overlapping length what you are getting, that is this length we call as lap length. So already you have one, this end is fixed, the length on the this end is fixed, so this end is 200 mm. So out of total you have 690 mm as you got. So from 690 mm, if you deduct 200 mm, it will give you the length you need to weld it on upper side, that is this side and this side. That is what we have calculated. It is 690 minus 200, whatever remaining length is divided by 2, you will get the answer as 245 mm. So here you can this length you can take it as 245 mm. Hence the lap length required is 245 mm. So this is the how we solve the problem. Next, coming to the next problem, it reads something like this. An ISLC, that is Indian Standard Light Channel 300 at 324.7 Newton meter of grade Fe 410 is used to carry a factored load of 900 kilonewton. The factored load is given and the angle is also given. It is ISLC, it's a channel section, and the channel section is to be welded at site. The condition is also given, it is at site, to a gusset plate of thickness is also given, it is 12 mm thick. Design the fillet weld if overlap is limited to 350 mm. It is a very important thing given. You need to, the overlapping length, you can see here the overlapping length is fixed, or the lap length is fixed. It is given as 350 mm. So the thing is, the load is also given here. Load is 900 kilonewton, and the channel section what you are going to use also it is given in the problem. So it will look something like this. This is the isometric view of the same thing. Here the lap length 350 mm is also fixed. So the first thing you need to do here is, what is the length of weld required for this particular load, that is for 900 kilonewton of load, what is the length of weld required, that is L is equal to how much. This is what we need to calculate. So first we will calculate by stepwise. When you're going with the stepwise, the first step is to select the weld. So from steel table you can get the properties of ISLC 300. From steel table, if you refer, the thickness of flange is 11.6 mm and thickness of web is 6.7 mm. So in order to select the size of the weld, it is very important you should know the thickness of the plates what you are going to connect. So from, if you refer the IS code book from table 21, that is from table 21 page number 78, and the plates you are going, what you are going to connect has a thickness of one is 6.7 mm. Second one is the thickness of the thicker part, that is the gusset plate, which has a thickness of 12 mm. So thickness of the thicker part what you are going to connect has a thickness of 12 mm. Hence minimum size of the weld from table 21 page number 78 is 5 mm. This is what the minimum size of the weld. Hence next is similarly you have the some other clause from IS code book IS 800 2007 from clause 10.5.8.1 page number 79. Maximum size of the weld is equal to minimum thickness of the plate which you are going to connect minus 1.5 mm. This is what the clause says. So minimum size of the plate what you are going to connect is one is 6.7 mm, second one is 12 mm. Out of these two, minimum size of the plate you are going to connect is 6.7 mm. Hence maximum size of the weld you can adopt is 6.7 minus 5 minus 1.5. So you will get maximum size of the weld what you can use is 5.2 mm. Hence we need to choose one size. Minimum is 5 and maximum is 5.2. Hence we will select the size of the weld as 5 mm. Okay, the next thing is next we need to calculate the length of the weld. For that, you can see here the length. For calculation of length of the weld, load is 900 kilonewton, and for that we can use this formula. It is area of the weld into stress of the weld. Okay, area of the weld is nothing but L into T into FWD. Here we already selected size of the weld as 5 mm. Hence we can use the throat thickness as 0.7 into 5, and FWD is nothing but FU divided by root 3 into 1.5. FU is 410 and root 3 into 1.5 is the field weld. When we use field weld, gamma MW becomes 1.5. Hence we will get the answer as length required is 1630 mm. Hence here the problem is when we have the total length required for welding is 1630 mm, but the problem here is the length available is one is 350 mm is the fixed upper side. Similarly the downside is also 350 mm. On the side you can weld, this is 300 mm. On the back side of this also you can weld, that is also 300 mm. So altogether you have 300 plus 300 plus 350 plus 350, so it becomes 1300 mm. But the required length is greater than available, hence we need to go with the slot weld. We need to provide a slot. Hence you can see in the figure we have made a slot of 180 mm so that it will increase the length of the weld. When we apply a slot of 180 mm, you can see the length is increased and we have the total available length now as 180 mm plus 180 mm top and bottom, and plus 300 mm, that is this side, and one more 300 mm, that is in the back side, and 350 mm here and 350 mm on the downside altogether. So total available length here will be 1660 mm, which is greater than 1630 mm. Hence it can be provided. Going to the next problem. In this problem, a tie member of a truss consists of an angle ISA 65 into 65 into 6 mm of grade Fe410 is welded to 8 mm gusset plate. Design the welded joint to transmit a load equal to full strength of the member. Assume site weld. It is given assume site weld. Here in this problem you can see two members are connected, or two plates are connected. One is angle which has a thickness of 6 mm. Second one is gusset plate which has a thickness of 8 mm. Okay, that is what we are written here. Gusset plate has a thickness of 8 mm and thickness of angle is given as 6 mm, and grade of steel is given, it is 410 mm, and the load for which you need to design the weld is full strength of the angle. Okay, so first thing you have to do is calculate the full strength of the angle for which you are going to design the weld. Okay, so What is full strength of the angle? This we already discussed. From class 6.2, page number 32, full strength of the angle is nothing but AG into Fy divided by gamma m naught. And from page this steel table, gross area of the angle, you will get the answer as 7.44 centimeters square, which is equal to 744 mm square. So Fy is nothing but yield strength, it is 250, and gamma m naught by yielding you will get it as 1.10. Substituting in the formula in this, we will get the answer as 169.09 kilonewton. This is the full strength of the angle for which you are going to design the weld. Next part, what you have to do is select the weld size. So from table 21, page number 78, you need to select the minimum size of the weld. So two plates you are going to connect. One is the angle which has a thickness of 6 mm. Second one is the gusset plate which has a thickness of 8 mm. So up to 10 mm, the minimum size of the weld required is 3 mm. Hence just minimum size of the weld required is 3 mm. We have selected it. And we have one more clause from class 10.5.8.1. Maximum size of the weld required is, that is, yes, should be less than minimum thickness of the plates what you are going to connect minus 1.5. Hence minimum thickness of the plates what you are going to connect is 6 mm and 8 mm. Out of these two, minimum is 6 mm. Hence it is maximum size of the weld should be less than 6 minus 1.5. We get the answer as 4.5 mm. Similarly, we have one more clause, that is clause 10.5.8.2, which says that maximum size of the weld should be less than 3/4 of the minimum size of the plate or the angle what you are going to connect. Hence it is 3/4 of 6. We get it as 4.5 mm. So out of these we need to select the size of the weld. So minimum required is 3 mm and the maximum you can provide is 4.5 mm. Hence we will select the size of the weld as 4 mm. Coming to the next, the one more problem here we have is the CG of the angle is at a distance of 18.1 mm like this. So now the thing is, if we have a CG at different point, we need to coincide it. For example, you can see I have written in the note, center of gravity of the weld should coincide with the center of a section used. Here the section used is an angle section. So CG of the angle and the center of gravity of the weld should coincide. So what we can do is, we need to provide separate lengths. In the top we will provide different length, in the bottom we will provide different length, so that average CG of these two will coincide with this particular line. So now you need to find what is length L1 and L2. How we can find L1 and L2? Imagine the strength or the load taken by weld L1 is P1 and load taken by length L2 is P2. Okay, if that is the case, then we will take a moment with respect to A. When we take moment with respect to A, we will get, with respect to A, P1 is acting anti-clockwise, so minus P1 into perpendicular distance from A to this is nothing but 65. So minus P1 into 65. With respect to A, this load P is acting clockwise. So P into distance is 65 minus 18.75. So I have written the same thing here. Okay, I have written the same thing here. So from which we will get the answer for P1 as 122.004 kilonewton. And since we are going to we got the answer for P1, we can easily calculate the answer for P2. That is, the total load is 169.01, out of which P1 we already got. So P minus P1 will give you P2. Hence, P2 is equal to 160. P2 is equal to P minus 122.04. P is nothing but 169.09. When you substitute, you will get the answer for P2 as 47.086. Here, you need to calculate L1 and L2 based on the proportion load. First, we will go with the calculation of L1 where we use P1. So P1 is equal to area of the weld into stress of the weld. Here you can see it is written as P1 is equal to L1 into T into Fu divided by root 3 into gamma md. This particular value, we say this as strength of weld for 1 mm length. Okay. So this already I have written. If we calculate this separately, it makes easier for the calculation of length for the further next value. For example, we are going to calculate it for 122.04 kilonewton. So L1 is equal to, here we substituted T is equal to 0.7 into 4 into 410 is Fu divided by root 3 into gamma m naught. When we substituted, we got the value here. You can see it is L1 into 441.865. This value 441.865 is nothing but strength of the weld for 1 mm length. So L1 is nothing but load divided by 122.004 divided by strength of the weld for 1 mm length. If you substitute directly, you will get the answer as L1 is equal to 276.11 mm. Similarly, we can calculate L2 by direct substitution, that is L2 is equal to we can go with the direct substitution. L2 is equal to P2 divided by 441.865. So directly we will get the answer. You can see the same way we have substituted P2 is equal to L2 into strength of the weld for 1 mm length. So L2 is equal to 47.086 divided by 441.865. When you substitute, you will get the answer as L2 is equal to 106.56 mm. So L2 is equal to 110 mm. This finishes the problem. Suppose if the same question comes with 3-side welded connection, then we need to calculate P1, P2 and P3 separately. Okay, but the one advantage you have here is calculation of P3. Here you can see in the calculation of P3, the length is already fixed. L3 is already fixed and L3 is nothing but 65 mm. It is the length of the angle. Okay. Hence, since you have length of the angle L3 as 65 mm, you can easily calculate what is P3. Okay. So first thing you have to do whenever you get a problem like that, you need to calculate P3 first. You can see P3 can be calculated as L3 into strength of the weld per mm length. Strength of the weld we already calculated. It is 441.865 and length of the weld is 65, from which you get the answer as 28.72 kilonewton. So P3 we got. Next we will go with the same concept. Take a moment about A. You can see here if you take a moment about A is here. If you take moment about A, with respect to A, P3 is acting anti-clockwise, P1 is also acting anti-clockwise and P is acting clockwise. With respect to A, P3 is acting at a distance of 65 divided by 2 and P1 is acting at a distance of 65 and P is acting at a distance of 65 minus 18.1. The same thing I have written here in this particular point, from which you can calculate only one unknown is there, that is P1, so you'll get P1. And we know that total load P is equal to P1 plus P2 plus P3, and when you substitute in the equation you will get the answer for P2. Once you get the answer for P2, directly we can calculate what is L1 and L2, length in first point and length in second point, that is L1. This L1 and L2 we can calculate. Okay, so it is again using the direct formula. L1 is nothing but P1 by strength of weld per mm length, and L2 is nothing but P2 divided by strength of weld per mm length. So the same calculation is I have written here. You can see L1 is P1 divided by 441.865, L2 is P2 divided by 441.865. So from which you will get the answer for L1 as this one and L2 as 75 mm. So this is how we used to calculate if it is provided on three sides, if the weld is provided on three sides. Next we'll go with the next problem. Here in this problem you can see we have two angles connected on either side of the gusset plate. Okay, so the problem reads like this: design a sharp welded joint for a member in a truss consists of two ISA 100 into 75 into 8 mm welded on either side of the gusset plate of 12 mm thick by longer legs, subjected to a working force of 300 kN. Assume plates of Fe 410 grade. It is given like this. So here you need to note that angle is 100 into 75 into 8 mm, out of which 100 mm leg is connected to the gusset plate, and thickness of the angle is 8 mm and the thickness of the gusset plate is 12 mm, and working load is given as 300 kilonewton. Whenever it is given working load, you need to take the factored load. So factored load is nothing but 300 into 1.5, what we will get it as 450 mm. It is I have written here. The view of isometric view of that is written here. I have shown here. It is something like this. When you see from the side view, it will look. When you see from the side view, it will look something like this. So next onwards we will be dealing with the side view only. So you can see here total load taken, that is 450 kilonewton, whatever is there, this is taken by two plates together. So if we design one angle with 225 kilonewton of load, that is sufficient. So we will only design one angle with 225 load, which will be same on the other side of the angle also. Hence we will see the angle. Now the problem is same as the previous problem. Here the load is given 225 kilonewton, and CG of the angle is 31 mm. This we got it from steel table, and same thing you have to do. You need to find the L1 and L2. Before that, first thing you have to do is you need to calculate what is the size of the weld. So first step is finding the size of the weld. In order to find the size of the weld, two things you have to keep in mind. One is size of one for angle, that is 8 mm. Second one is size of the gusset plate, that is 12 mm. So minimum size of the weld required depends upon these two parameters, that is 8 mm and 12 mm. Out of these two, the thickness of the thicker part is nothing but the 12 mm. For this 12 mm, the minimum size of the weld required is from the table IS 800 2007, from table 21, minimum size of the weld required for 12 mm size is 5 mm. So size of the weld minimum required is 5 mm. Again from the clause, from clause 10.8.5, 8.1, 10.5.8.1, page number 79, maximum size of the weld is S, which is less than 8 minus 1.5. That is the thinner part which you are going to connect. So out of these two, that is 8 mm thick and 12 mm thick, thinner part is 8 mm. So it is 8 minus 1.5, which is 6.5 mm. Similarly, from clause 10.5.8.2, we have size of maximum size of the weld S should be less than 3/4 of 8. Hence, we get it as 6 mm. So, minimum size of the weld is 5 mm, and minimum size of the weld is 5 mm, and maximum size of the weld you can provide is 6 mm. So you need to choose in between these two. Hence we will select 5 mm for the welding. So we have selected size of the weld as 5 mm. Once we select the size of the weld as 5 mm, we will calculate strength of the weld per mm length. Here L is nothing but 1 mm length. We just substituted 1 into 5 into 0.7, that is the throat thickness is 0.7 into 5. Fu is 410 divided by root 3 into 1.25. We will get the answer as 662.79 is the strength of weld per mm length. So again we take the moment about A, same as previous problem. When we calculate like that, we will get answer for P1. P1 will be 155.25 kilonewton. That is, we are going to take moment about A. Take moment about A, it is minus P1 into 100 plus 225 into 100 minus 31 mm. The same thing you are written here. It is minus P1 into 100 plus 225 into 100 minus 3, from which we got P1 is equal to 155.25. Again, if you take total load P is equal to P1 plus P2, if you go like this, you can from which you will get the answer for P2. P2 will be equal to 69.75 kilonewton. Now we need to calculate length L1 and L2. Here nothing is mentioned about sides. We will choose only two sides, top and bottom, as shown in the figure. So L1 is equal to P1 divided by strength of weld per mm length. So we have substituted this. So when you substitute, you will get the answer as L1 is equal to 235 mm. And similarly, I have substituted for L2, and we got the answer for L2 as 110 mm. So this finishes the problem. We will go with the next problem. Next problem. A circular plate 150 mm in diameter is welded to another plate by means of 6 mm fillet weld as shown in figure. Calculate ultimate twisting moment that can be resisted by the weld. Use steel of grade Fe410 and shop welding. Okay, the problem is something like this. You have a smaller plate here. You can see this is the smaller plate here, which is connected to a bigger plate by using 6 mm fillet weld. Diameter of the plate is given. Diameter of the plate is 150 mm, and you need to find what is the twisting moment that can be resisted by this particular weld. So it is very simple to calculate. First, what you have to do is we need to calculate what is the moment taken by 1 mm length weld. It is nothing but strength of 1 mm length weld multiplied by lever arm. Lever arm is nothing but the distance from the center to the periphery of the weld or up to the weld. It is nothing but 150 divided by 2. So the lever arm is all, it is 150 divided by 2. So solution for this is very simple. First, we need to calculate strength of the weld for 1 mm length, that is area of the weld into stress. Area is nothing but length into throat thickness. Length is 1 mm, and throat thickness is 0.7 into 6, and substitute Fu divided by root 3 into gamma m naught, mw. So you will get the answer as 795.35 Newton. So the moment resisted by 1 mm weld is nothing but strength of the weld into lever arm. Here you can see the lever arm is 150 divided by 2. So 795.35 into 150 by 2 will get the moment resisted by 1 mm weld. Now since we have on the roundabout we have this much length of the weld connected, we need to calculate what is the length throughout this length. So it is we can calculate the length of the weld as it is nothing but pi into d. So pi into d is nothing but total length of the weld. It is the periphery of the circle. So pi into d, we get the length of the weld as 471.23 mm. Hence total twisting moment, ultimate twisting moment is nothing but strength of 1 mm or the moment resisted by 1 mm, that is 59.65 into 10 raised power 3, multiplied by total length of the weld, that is 471.23. So you will get the answer as 28.109 into 10 raised power 6 Newton millimeter, which we converted into kilonewton meter. It is 28.109. So this is the answer. This finishes our topic. Thank you.